This lesson is about velocity-dependent friction or drag force. Welcome to Physics is Easy with Mr. Jesse. Drag force is a force that is being exerted by fluids as objects fall through them. So when I say fluids, that would be liquids and gases. So for example, if we drop an object, the object is going to experience air resistance, and in fact air resistance is an example of drag force. So if we are going to drop a stone in a pond or in water, it would also experience water resistance, so that is drag force. Now for this lesson, drag force, will take this formula is equal to kV. In some books you would also say, or in some cases you would also say F drag is equal to kV squared, but for today or for this lesson we are going to focus on kV, where k is the drag constant and v is the velocity of the object. Now k actually depends on the type of medium or the type of fluid through which an object is falling. So for example, the drag constant of water is different from the drag constant of air because they are different types of fluids. Also, we could see in this equation that F drag is equal to kV, meaning to say that when our velocity increases, our drag force also increases. So once again, this means then that the drag force increases as the object moves faster. Let us now look at the next video to understand the application and the importance
When a
of drag
skydiver
force.
jumps out of a plane at 3,000 meters, her speed goes through some big changes. To explain how all these changes in speed occur, you need to think about the forces involved. So what's happening to the forces as you fall through the air? The force of gravity is always trying to pull us towards the Earth. Before the skydiver jumps, the floor of the plane provides a counterforce which balances the downward force of gravity. Right? Gravity immediately pulls her towards the ground and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity. When forces are balanced, the speed remains constant. That doesn't mean she's stopped falling, it means she's stopped accelerating. She's still doing a steady 55 meters per second, and hitting the ground at this speed isn't a good idea. To slow down, the upward force needs to be greater than the downward force. When the parachute opens, air resistance suddenly becomes much greater than gravity. The forces are no longer balanced, and this changes her speed. She slows down. Because she's slowing down, air resistance decreases until it balances gravity again, and she reaches a much slower constant speed. Approaching the ground at 5 meters per second is a much better idea. As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her very quickly. So, for skydivers to land safely, they need to understand forces and use air resistance to slow themselves down.
So once again, drag force increases as the velocity of the object increases. So for the case of a skydiver, the drag force increases as the object falls down because its velocity increases as the object is falling due to the acceleration due to gravity. And if you notice, at the start, where there's no drag force, the acceleration due to gravity is equal to negative 9.8 meters per second square, or meters per second. And then as the drag force increases, the acceleration also decreases until such time that the acceleration becomes zero. So this happens when the drag force is equal to the force of gravity. So in this case, the drag force is equal to 882 newtons, and the force of gravity is also 882 newtons directed downward. And once again, when the drag force is equal to the force of gravity, the object will experience an acceleration of 0 meters per second square, and at this point we say that the object has reached its terminal velocity. So by definition, terminal velocity is the maximum speed achieved by an object that is falling under the influence of a given drag force. It is reached when the magnitude of the drag force is equal to the magnitude of the weight of the object. So if we are to draw the free body diagram of the object, say for example this is the object right here, the forces acting on the object when it has reached this terminal velocity would be the following. We have the weight of the object downward, and we have the drag force in the opposite direction. And in this case, we'll call it F drag or FD. In this case, the magnitude of the drag force is equal to the magnitude of the weight of the object. Let us now relate this lesson to Newton's second law. According to Newton's second law, we have F net is equal to ma. Now when the object has reached terminal velocity, so we say at terminal velocity, we'll call that Vt, the upward force or the drag force, F drag, is equal to the weight of the object. So relate that to Newton's second law, the F net would just be Fd minus the weight is equal to mass multiplied by the acceleration. And since the object is now moving with a constant velocity, therefore the acceleration is 0. So now let's expand this. The drag force according to the previous slide is equal to kV, that's drag force, and that is minus the weight of the object, which is mg, that is equal to 0. And this happens once again, this only happens when we have reached the terminal velocity. So I'm gonna call this velocity right here as Vt, so meaning the terminal velocity. Let me write this down properly. Vt is terminal velocity. Alright, so manipulating this equation, this tells us then that Vt in fact is just equal to mg divided by k. But what if the object has not reached its terminal velocity yet? What would be the equation of the velocity that we could use? Okay, once again, let's start with Newton's second law, that is F net is equal to ma. And if we draw the free body diagram of an object that's falling, we will have the weight directed downward and that drag force directed upward, which changes as the velocity of the falling object changes. So we say F net, the forces acting on the object would be F drag minus the weight of the object, and that is equal to mass multiplied by the acceleration. Now the acceleration in this case is not 0 because the object has not reached its terminal velocity. Now recall that acceleration is just equal to the derivative of velocity with respect to time, or dv dt. So I'm going to use that then. So we will have drag force, and also F drag is also equal to kV. Now kV, let me just fix that. It's kV. And weight is equal to mg. So let us substitute all of these expression into this equation that we have here previously. Right, then we will have Fd is kV minus the weight of the object, which is mg. That is equal to the mass of the object m multiplied by the acceleration, and this time I'm going to call that dv dt. Alright, so manipulating this equation further, this would give me, I'll divide both sides by m. I'll divide it by m. I'll also divide it by m, such that I will now have dv dt is equal to kV minus mg all over m. This expression right here is an example of a differential equation. Let me write that down first. Now, a differential equation is a kind of equation wherein the derivative of a function and the function itself is present in one equation. So, for example, we have the function velocity, and we have the derivative of the function. So this is the derivative of the function, and that's the function right there. So if both are actually present in one equation, that is an example of a differential equation. We would not be solving this differential equation. I'm just actually showing you this, because if you would proceed to higher physics, you could actually learn, or higher mathematics, you would know how to solve this particular differential equation. But for now, let's leave it at that. And once again, be reminded that dv over dt is in fact equal to acceleration. So acceleration is equal to kv minus mg over m. And that concludes this lesson. I hope you learned something about drag force, terminal velocity, and the differential equation that relates to the velocity of objects under the influence of drag force. Thank you for watching. This is Physics is Easy with Mr. Jesse.